In this lesson, we're going to learn how to calculate the best fit line from a scatter plot. We're going to call that the least square regression line. More on this later on why it's called that and some of the special characteristics. But for now, that's what we're going to call it, and we will abbreviate it as the LSRL. So we're going to predict and interpret from that today, and we will also learn to calculate a residual. Okay, so this is our best fit line. This new notation, y hat, is the predicted response variable. Here's my y-intercept, my slope, and x is my explanatory variable. I'll also call this your regression model, so your model is literally an equation. Let's talk about the y-intercept, which is our a value in this equation. So a is when x is 0, what's the predicted y? But we're going to use our interpretation in context. So this is kind of a fill-in-the-blank statement you can use. I'll show you an example shortly. The slope would be that for it's a change in y over change in x. So for each additional increase in our x value, the predicted y is either going to increase or decrease by what that slope is. These two concepts are really not much different from Algebra 1, just super important that you're talking about your predicted y value in both statements. Let's illustrate this today with these 16 data points, which are the miles driven and the corresponding price of a Ford F-150 Super Crew cab that was listed for sale on autotrader.com. So this truck sold for this price. I would like you to enter this data into your calculator. A reminder to do this, you hit Stat Edit, and I already have my data preloaded in L1 and L2. To run a regression equation, I go back to my main screen and then I hit the following buttons. Stat, arrow over to Calculate, and then it is option 8. I want L1 and L2, which is where I've stored my x's and y's. I'm going to do one additional feature. I'm going to tell the calculator to, in a sense, store this equation it creates in a special spot. I want to store it in y equals. To do that, I hit Variables, arrow over to Y Variables, and it's the first one, Function, and there's all my y's. I'll just select y1. So it placed y1 here. I go down to Calculate, and here is my a, my y-intercept, and b is my slope. Down here are, there's your correlation coefficient, showing that there's probably a moderately strong negative correlation, as long as we really should only calculate that if we have a linear relationship. So let's quickly look at our scatter plot. So second stat plot, and it's already turned on. There we are. L1 and L2 are in the right places. So you can zoom 9, and right here is my graph. Looks fairly linear, negative, moderately strong association. Additionally, you can see my best fit line was drawn. How did that happen? Well, when I hit y equals, that equation it just calculated automatically went where I told it to y1. So it's helpful to see my best fit line, or my LSRL as it's called. So I'm going to look back at the equation and we're going to write it in the proper format. So I'm just going to run it one more time. There's the output from my computer screen, or calculator rather, and here is how we're going to write this. I use predicted price. I don't put y hat, I put price hat. So I'm defining my variables within the equation. There's my y-intercept, my slope, and again, x is miles driven. We're going to now use this regression model to predict the price of the truck with 100,000 miles on it. Easy way to do that is if I hit the trace feature and I arrow up so that my cursor is on the best fit line, I can hit 100,000 down here, hit enter, and notice the prediction falls exactly on the best fit line of $21,965.28. I'm going to do it by hand, because if you get a free response question on the AP exam, you're going to take your best fit line, you plug in 100,000, do the math on the calculator, and there's my predicted price. And a little bit of context. So a Ford F-150 with 100,000 miles on it is predicted to sell for $21,967.14. Notice that's a little bit off from what the calculator has, and that's because the calculator went to all of these decimal places so this is slightly more accurate. Can we use the model to predict the price of a Ford F-150 with 200,000 miles on it? Well, the real answer here is, sure we can, okay? So I plug in 200,000, there's my answer, but I have a problem. That 200,000, if you look back at your original data, is outside all of the mileage that we had to look at. So this is an example of extrapolation. So the model predicts that a truck with 200,000 miles on it will cost $5,677.14. However, we really need to be very cautious with this prediction, as 200,000 is an extrapolation of the relationship beyond what the data show. So be very wary of extrapolations, interpolations, when we use a value within our data set. Those are much safer. That's where the model is reliable. The model is unreliable outside our given values. So what does the y-intercept mean in this context? Well, it says, so it's when your x is 0, and I'm going to have context. So when the Ford F-150 is brand new with 0 miles on it, the predicted selling price on Auto Trader is that $38,257.14. What does the slope mean? Well, the slope is for each change in your x value, how much does that y change? Okay, so I kind of start with the denominator. So for each additional mile on the F-150's odometer, the predicted selling price decreases by this much. Decreases because the slope was negative. Let's define what a residual is. So residual is the distance from the prediction of the model, how far an observed value is from that one that's predicted by a model. I remember that by AP. You're in an AP course, so residual you subtract in that order. Here's my interpretation in general, but I will, of course, show you with an example where it makes a lot more sense. Here's that same data, that Ford F-150. Okay, so these red points are the 16 trucks and their corresponding price. So for instance, this one right here is what it was observed to be, but the model would have predicted that the price is up here at like 32,000. So the model over-predicted in this scenario. This would have a negative residual. This data point has a positive residual because it's above the model. In this scenario, your model under-predicted the cost of that truck. Interestingly, these residuals, okay, the calculator is reducing this distance, and if you would add all these residuals together, it will equal 0, but more on that later. So we're going to calculate and interpret the residual for the truck that had this many miles and sold for that $21,994. So that looks to me like it is 70,000 is right here. That's 75,000. So with looking at this, I know my residual is going to be a negative value. Here's how to calculate it. We're going to take our best fit line. Okay. This is the actual. So A, here's what it was, subtract what the model predicted. So all I've done is I've taken this value and plugged it in to our regression model, and I do the math. I get this negative residual, like the picture showed. So that tells me that the actual selling price was $4,765.17 lower than what was than the predicted selling price for a truck with that many miles on it. So I could also say that the model overpredicted. Similarly, here's just another example. And this one, the truck had 140,000 miles on it, and it sold for 20,000. So same thing. I put the actual right here first, and I subtract what's predicted by the model. So this is me substituting the X variable in. I get a positive residual. So the actual selling price was $5,572.27 higher than the predicted selling price for a truck with that many miles on it, the 140,776 miles. In this scenario, the model under-predicted. Lastly, just because I want to reinforce this correlation coefficient concept, what is the correlation coefficient of the regression model? So again, we get that from our calculator by running our regression. So we do stat calc option 8, and I'm just going to calculate it again. Here it is. Okay, so what is this doing? R addresses two things, the strength and direction of a linear model. So you really should only calculate R if the model was linear. We confirmed it was linear. So a correlation coefficient of negative 0.815 confirms that the linear association between the miles driven on the Ford F-150 and the selling price on AutoTrader is fairly strong and negative. Okay, so I'm putting this linear part as if it's the condition, and then it verifies that it's fairly strong and negative. All right, there is a quick lesson on how to find the regression line on the calculator, how to calculate residuals, and interpret the different parts of it. Reach out with questions.